there are big catches for moving into the cloud, and you kind of got to read the fine print and make sure that you know what they're saying when you sign up for things. And some of it is contractual stuff. That's usually not the big one. The biggest catch I find with cloud stuff is that the stuff you're putting up there quickly becomes extremely important. It becomes extremely important, but it was put up there probably by a bunch of people who found your existing procedure for getting resources that are supportable to be onerous. So they sidestepped your standard support procedure. So all the people who should know what's involved with the software, what's needed to support it, they weren't involved in any of this because they were sidestepped. So there's a few things we kind of end up looking at. So here we go. And here's some of the other issues. Maintenance windows are awesome with Amazon. Amazon always promises that, and this is Amazon specifically, that they will warn you ahead of time that they're having a maintenance window. So when they're having a maintenance window, and you've got your 2 weeks of notice, you need to shut down your machines, move them to a different data center. Everything will be fine. And you bring them up there. Easy. And in a former life, at a different client, I can remember getting those emails that said, we've started our maintenance window, all of your instances have been shut down. Wait, what? What? We didn't find out about that. And you'd call, and if you could ever get a hold of a person, which you really can't, you'd send emails. And sometimes you get a guy to admit, oh yeah, we had a little problem with the alerting system, so we were supposed to tell you last week, but anyway, the data center's down now, so we'll be back up in 8 hours. And we were reselling servers, so that was fun. We had a nice customer-facing outage on that. We've got non-portability of images as a fun pain point. And this is kind of any virtualization technology. You build your images for VMware, they run on VMware, they don't run on VirtualBox. You build your images to run on Amazon, they're going to run on Amazon, they're not going to run on Google. You might have tools to convert it, but once you pick a cloud computing vendor, you're going to be with them for a little while, once you've really committed. And you've got to realize that there's going to be effort and money involved in moving something over to another place. Amazon is a master of Byzantine pricing. It's spectacular. If you can figure out exactly what you are going to pay for next month, given a set of traffic, please talk to me after the meeting, because I've got a lot of formulas that could really use fine-tuning, and I need your help. They charge for things like 1 million IOs, but it's a little vague on what your IOs are, and that can be interesting when you're setting up a database. You know, are you being charged for the data going out to the customer? Yes. Are you being charged for the data coming from the customer? No. Are you being charged differently for a customer in Europe than in Japan? Yes. But if you've got the machine in Japan and the customers in Japan, that's one pricing model. If you've got the machine in Europe and the customers in Europe, that's a different pricing model. It's entertaining. It is very, very Byzantine. Now, the other thing you've got, you pay by the hour. But it's kind of an interesting hour mark, because if I spin up 10 machines on Amazon for 5 minutes each, all at once, that's 10 hours of computing charge. But if I spin up 10 machines on Google at once and let them run for 5 minutes, that's 1 hour, because 5 minutes times 10 machines is 50 minutes. That's less than 60 minutes. That's an hour. So it's very different pricing models. And this is actually one of the things I really like about Google's offering coming up, is their pricing model looks to be simpler. With Amazon, going to run a machine this month? No problem. We'll pick a very small machine. We'll charge you 2 cents an hour. You say, oh, 2 cents an hour, that's a lot. And they say, no problem. Pay us $60 up front, and we'll charge you 1.3 cents an hour. Oh, that's pretty good. Can you get it any lower? And they say, fine. How about $85 this month, and we'll charge you 0.9 cents an hour, but you got to pay for all the hours in the month. Oh, well, it often feels like a game of 3-card Monte. The little P is moving around. Good luck finding it. Google is hoping to knock them off. We'll see how this works out for them. Now, the other thing you don't have is you don't have physical access to the machine. You can't go down and flip the power switch on the box. Big deal. I mean, I hear people complain about this, and my thought is, I haven't been at a place in 5 years where I could actually get physical access to the machines. Personally, I don't want physical access to the machines because if I can get to it, I might be expected to swap a failed drive. So no physical access is good. I could go into lots of reasons why I don't want anybody on the machine room floor, but most of it is just environmental stuff. So, and this last one, it's kind of a nebulous fear that people have. Where are these machines? I don't know, it doesn't really matter. I mean, Google has talked about building a data center near Duluth for better cooling. They've got one in Council Bluffs. Amazon has these things scattered all around. I really don't care where the machines are as long as they've got internet and power and relative physical security. And I guess I can look at this and say, well, if I don't know where they are, most people probably don't know where they are. That's good physical security. Nobody can break in.
Security through obscurity.
Now, there's a couple of things that we want to do past all those fears. And most of those I consider to be minor stuff. Even the pricing stuff, you can get a feel after a while what it's going to cost you. The bigger problem is all of these systems that have grown organically. You've got now a bunch of machines. We'll say it's a relatively small cloud deployment. You've got 35 machines out there. They're customer facing. It's a web application with database backend. Cool. And this is neat. We never could have gotten this built before because we're using Tomcat instead of WebLogic, and our backend is PostgreSQL, and our corporate standard is SQL Server. And look at this, we aren't paying any license fees, and everybody loves it, except now the guys who know how to support SQL Server and WebLogic instead of Tomcat. Now they might have to look into this. And the guys who built this probably are guys who built things rather than maintain them. So what can we do? What can we do to make sure that our machines stay really in a known state? Because machines in an unknown state scare me. It makes me very nervous when somebody says, well, we're not really sure what's been happening with machine X. That's a very bad situation. There are essentially three things we want to do, and the first two kind of fit together a little bit. Intrusion detection, system monitoring. So we want to make sure that nobody's changing anything on the machines. Nobody's logging in when they shouldn't be. Whether they're bad guys logging in from Belarus or somewhere else in the Eastern Bloc, because invariably that's where they log in from, unless it's Ohio. Or if, worse in my case, if it's the actual developers logging into a machine. In a former life, the developers would log in on like Saturday at midnight and suddenly do a code deploy in production. And the alarms would go off after we put the alarms in place. And I'd call the guys, like, what are you doing? I'm like, well, we had to roll it in production. Why? You don't have a window for this one. It broke in staging. Great. Okay, good. That's one approach. And then we'll talk a little bit about this neat thing called drift management. And this is kind of the natural effect of just having a machine, system drift. People make changes. They find that as initially imaged, your machine wasn't quite right. It was missing a service account. It had permissions wrong on a file. Hey, we forgot to install an important piece of software. All of these things are your system drifting away from what the original image was. Whenever it drifts away from the image, that means the next time you go to build it, it's going to come up wrong. And it might come up just a little wrong. It might come up so that it's just missing one guy's account. Okay, that's not so bad. It might come up wrong enough so that your, I'm trying to remember, that your WebSphere application server will no longer even start. In that case, that would have been a 16-node cluster that had drifted far from the official specifications. So when we finally patched it to try to bring it back to a known state and rebooted it, we found that it turns out there had been a lot of custom kernel settings that no one had ever written down or made a note to check beforehand. Drift is invariably a natural result of just your systems being used. And documentation often lags behind reality. So And the other thing that it comes up is when you're doing compliance audits, PCI audit, DISA STIG is a government security standard that I used to work with a lot when it was still named DISA STIG, and now I think it's SRG. They change the acronym every now and then to keep us on our toes, but I don't do it anymore, so I don't need to know. But it had a big set of rules, you know. Password's got to be this long. Password's got to be changed this often. File permissions have to be like this, except in these cases. And so you'd go through and run reports on everything to make sure your machines were still in compliance, which I always thought was a little short-sighted. Telling me that my machines are out of compliance, great, now I got to go fix something. I don't like that. I am by nature a lazy man. And that's why I say if you're going to control drift, reporting just isn't good enough. You've got to have something in place so that as a machine drifts, it's brought back into compliance. And you don't want someone having to do this manually. So this big reporting thing. In fact, I can remember one client I worked with who wanted to turn off the automatic remediation we'd set up because it screwed up their reports. They'd say, well, we can't tell how many machines are out of compliance with the password policy because you keep fixing them whenever they go out. And I thought, I'm not sure these reports are what you think they're for. You know, they should always come up with no machines are out of compliance. And this is the big take. I remember saying that in a meeting. I remember accusing a guy saying, man, if you were a bank auditor, you would just want to know when somebody had left a vault open. It's like, well, yeah, I'd want to know when somebody had left the vault open. I said, well, that's the difference between you and me. I want to put an automatic closer on the vault so as soon as somebody steps out, the thing slams shut. And he didn't think that was funny at all. So how do we actually remediate this stuff? Well, Jenny likes this phrasing better because she's a better person than I am. I always say fall back and nuke it from orbit. That's one approach to do it. So we rebuild it, and this is often an issue because Rome wasn't built in a day. So if you're just going to rebuild your machine every time you find out that it's not what you think it is, you're going to spend a lot of weekends in the data center. Well, not in the data center, at your desk. We got manual remediation, which no. And the one on the bottom is the most important, automated. We want to automate everything.